And so let's start with the Daemon Code. This Daemon Code is really pretty straightforward. It's now just 150 lines. Its entire purpose is to, on setup, try to connect to the daemon using the Hyperspace client code right there. So it'll try to connect, and if that fails, it's going to go into the daemon launch process. It's going to try to spawn its own copy of the daemon. That's what this little bit of code is right here, which is a sort of a unique to Electron piece of code here. I'm basically getting the path of the Electron exe, or the application exe, and then calling the daemon by the daemon path, specifying a storage directory, etc. And then using some Electron things to say, just run the node process and don't use the ASR packing format, which is a whole thing that Electron does that we don't need in this case. And then we have this handle to the daemon process, which we can watch for information. For instance, if it logs anything, we can pipe that into our local logs. And we can also watch for that thing to die on us so that we can potentially deal with the loss of the daemon, restart it, things like that. So that's pretty much what the daemon control file is for. And then pretty much everything that everybody else cares about in the code base is this one right here, get client. Right? So once we're able to get the client, we can start to use it for things. Now, the interesting stuff is the structures.js. I called it structures. I needed a generic word for basically all hypercore data structures. You know, so hyperdrives, hyperbees, hypercores, anything that you can publish on the hypercore protocol. The hyperstructure.js is designed within uplink to be able to load it up and get you the right interface for it if it understands the data type. So that's what this file is here. And so anytime that I want to, that somebody hands me a hyper URL in uplink, it's going to call this get function. And it's going to look to see if it's already loaded, and if it's not, it's going to load the hyperstructure class with the key, called the load function, cache it, and that's that, right? So all the magic is happening right here, and this is pretty simple, right? It's just 111 lines, this entire thing. So, you know, in our constructor, we take the key string, hold on to that, and we've got attributes for the type, for the header block, and for an API to the hypercore data structure. And on the load, if this is the first time, we will, first of all, get the daemon client. So this is a client API to Hyperspace. We're going to instantiate a core store, and a core store is an interface to basically the data storage for hypercores, right? So I'm getting a handle to be able to load hypercores. And I ask for it to give me the hypercore for the key of the data structure we're working with, right? So all hypercore data structures are built on these hypercores that are logs of data. And I'm grabbing the hypercore API because I want to read the very first block inside of a hypercore. That's our step one. Because hypercore now is a self-describing system. The first block on a hypercore log is a little header block that says what type of hypercore data structure you're about to be interacting with. And that's good because that means that we can look at that block, detect what kind of data structure it is, and load the correct handling code. So there are two kinds that we handle currently, hyperdrives and hyperbees. So the first thing we're going to look for is to see if this thing is a hyperdrive. And internally, hyperdrive uses something called hypertry. We don't need to worry about that. It's just what type we're going to be looking for. So that's what we grab first. And if that decodes successfully, if our hypertry header decodes successfully and we see that it's a hypertry, and if the subtype doesn't tell us it's not a hyperdrive, then we stick with hyperdrive. And then we know we are looking at a hyperdrive, and that's that. Okay? So right here, detecting if it's a hyperdrive. If that doesn't work, and Matthias is telling me there's a more efficient way to handle this, but I'm doing it with this double try-catch bit. And I've got some half-written comment there, so whatever. So then we try again with the hyperbee header this time, and if that works, we know, hey, it's a hyperbee. Now that's actually not the right thinking, is it? Because it could parse successfully. So I actually need to tweak this. I think what I need to do is I need to have something similar to this right there. Is this type a hyperbee? And I believe it's called protocol in the case of the hyperbee header. Why don't we do a quick console.log and see if I can make this code a little more correct. See, this is the advantage of sitting and parsing through all your code. You find little mistakes like this. Okay, so let's load up that Hyper-B again, and we should see in the logs. Yeah, I was totally right. There's a little string inside the header block of a Hyper-B called the protocol, which will say Hyper-B. If it doesn't say Hyper-B, then we don't have a Hyper-B. So we need to do that check. And so we're going to do, if not this.header type, nope, protocol. It's not equal Hyper-B. And we're going to bounce. And that should be more correct now. So now if something showed up that wasn't a Hyper-B or a Hyperdrive, we wouldn't incorrectly see it as a Hyper-B, which is what would have happened there. Fixing that code. Okay. So that is the detection part of it right there, right? So we had this hypercore that we loaded up, we read the first block, we figure out what we're looking at, and then we throw away the hypercore. Well, we hold on to the hypercore actually, because we may want to use it. But the next step is to load up the API that's specific to that hypercore data structure. And I'm getting pinged, so let me make sure I'm not missing something important here. Nah, okay. Okay, so yeah, now we're going to load up an API that's specific to the data structure type. If it's a Hyperdrive, we're going to load up the Hyperdrive API. If it's a Hyper-B, we're going to load up the Hyper-B API. And that gets stored in the this.api for our class here. So, right, we got the type, which will be Hyperdrive or Hyper-B or Hypercore. I guess actually unknown would be, yeah. Then it's going to be the header block that we should just hold on to, because who knows, that may be handy. And then this API object, which we're instantiating here to be specific to which kind of thing we're working with. And once that API says it's ready, we are all set. And we can start using this data structure. So that's our sort of generic hyper data structure loading code. Let's make sure that's all working still. Looks like it. Okay, so so that's that part of it. Now the way that I'm actually interacting with these data structures sort of depends on whether or not I'm in the background process or in the foreground process. Electron applications are constructed almost like a client-server architecture, where you have the what's called the background process, which is sort of like the server, and then each window, or even actually sort of more specifically JavaScript context that gets loaded onto the page is like its own client, sort of like its own tab inside of a web browser. And so this whole UI is in the what you call renderer process. It's like the client side, and then the background process is hidden away. That's where all of the sort of persistent state and computation is living. So very similar to a traditional web application, which is nice because that's kind of what I know how to do. So whenever I want to interact with the backend to talk to these data structures, I use a little bit ago that I wrote this code, so let me refresh my memory by jumping into some of my front-end code here. But I believe that I have a little handy tool, Hyperstruct. And I'm gonna, do I have the URL? Yep. So let's move this down. I had to do some sort of like equivalent code on the client side. Let's zoom it in a little. Hyperstruct.get. And now I have basically a JavaScript proxy. I'm not going to explain JavaScript proxies, but basically they're like magical JavaScript objects. And anytime that I reference any attribute inside of this B variable here, it's actually, unless it's a couple of specific things like the URL, that's an actual real normal attribute. But most of the time, what it's actually going to do is create a function automatically anytime I access a property, and that function will call out to the back end of the uplink and call the correct function that's actually on the .api object here, right? So I've got this handle to right here, and if I do b dot, oh, what is the, let's do b.get type. I think that's right. Except it's only one exclamation point. There you go. With that, we get the correct value, uplink/userdb. And don't worry too much about that exclamation type convention. I'm not sure that's going to stick. That's just something I'm toying with right now. But the interesting thing is that b.get worked correctly. And what happened there is that when I call b.get, like I was saying, it actually doesn't... that's b.get is not an actual function on the b object. What happens is that the proxy gets invoked, and it generates this function right here, which is just sending the function call I'm making, turning it into some JSON, sending it into the backend, and then it's calling the exact same function that I just called on this.api. And so if we jump over to the code, we can see this is pretty straightforward. It's the hyperspace here, and it's call promise. That's what ends up getting called. The URL of the hyperstructure we're calling against, what method we're trying to call, and a list of arguments. It calls that structures.get to get the struct, grabs the API, looks for the promises one first. That's a Hyperdrive specific thing, don't worry about that. Calls the API method and returns. That's it. And as a result, we have this highly generic system for interacting with both Hyperbees and Hyperdrives. Nice and simple. And that was what I was working on right when I broke it.